Designing the power unit. All electronics devices requires a DC power source to operate. The input source can be from the 230-volt AC or base DC adapter or from battery. If the voltage source is the main 230-volt AC, it can be stepped down to the desired voltage using a transformer. A transformer is an electrical device used to convert AC power at a certain voltage level to AC power at a different voltage. Basic information needed when selecting a transformer: primary voltage, secondary voltage, and power rating. Example of a transformer specification: primary voltage 220 volt, secondary voltage 12 volt, rating 25 V8. How do you determine the current rating based on these information? The primary current can be determined by dividing the power rating by the primary voltage. This is the maximum current the transformer primary can tolerate. The secondary current is determined the same way. Base C to DC conversion. The basic half-wave rectifier circuit can convert AC to DC for most applications. The output ripple produced by these circuits is too high. The full-wave rectifier circuit with center tap transformer provides a continuous DC voltage from an alternating voltage. The full-wave bridge rectifier circuit also provides a continuous DC voltage from the alternating voltage without a center tap transformer. The filtered capacitor after the rectifier circuit improves the output voltage considerably. The capacitance of the filtered capacitor has an effect on the DC output. This is the output if the capacitance is lower. A larger capacitance results in a lower ripple. The design of a stabilized supplies has been simplified dramatically by the introduction of voltage regulator ICs such as the L78 and L79 3-terminal series regulators, which provide a very stable output and include current limiter and thermal protection functions. The 78XX series of 3-terminal positive voltage regulators converts varying input voltage and produces a constant regulated output voltage. The LM78XX series regulators are available with several fixed output voltages. The suffix 05 indicates that the output of this device is 5 volt. Notice that the input voltage needs to be higher than the output voltage. The LM78XX regulator maintains a steady output voltage by regulating the voltage drop across it. This voltage is called the dropout voltage. For example, if the input voltage is 14 volt, to maintain an output of 5 volt, 9 volt is dropped across the regulator. If the input is adjusted to 15 volt, the output remains at 5 volt. 10 volt is dropped across the regulator. With varying input voltages, the output maintains at 5 volt. The extra voltage is dropped across the regulator. The linear regulator functions like a variable resistor. The resistance changes, causing the dropout voltage to change in order to maintain a constant output voltage. The linear regulator does an excellent job, but not without its disadvantages. Its efficiency can be rather low. Assume the load current of 100 mA flowing. A voltage of 7 volt is dropped across the regulator to maintain a 5 volt output. The power consumed by the regulator would be 0.7 watt. This power loss increases with load current and input voltage. The power is lost as heat, which explains the need of heat sink for the regulator. The load consumes 0.5 watt of power, but 0.7 watt is wasted as heat. The efficiency is only 42%. The switching regulators work on a different technique to provide a more efficient voltage conversion. They usually cost more than the linear regulators. Operationally, the switching regulator is similar to the linear regulator, which gives a stable DC output of a desired voltage. The diagram shows a simplified circuit to explain the operation of the switching regulator. The switching regulator switches the input voltages to the circuit typically at a rate of 50 kHz to 100 kHz. How does the switching regulator work? When the switch closes, the input provides the source to the load and also generates an electromagnetic field in the inductor. When the switch opens, the electromagnetic field discharges and continues to support the current flow in the same direction. The switching provides a constant voltage output. The output voltage is controlled by the duty cycle of the switching frequency. If the switch is on for a longer duration, the output voltage rises. Reducing the on duration of the switch, the output voltage is reduced. The output voltage can be determined by the switching duty cycle. The Texas Instruments PT5040 is an example of an integrated switching regulator. The various versions provide for different output voltage requirement. Instead of designing the power supply unit, can we simply use a commercially available AC adapter which gives DC output voltage? Most of the commercially available AC adapters can be represented by the circuit shown below. The output is unregulated. This output may not be suitable to drive electronic circuits. Let's recap how we need to design a power supply unit based on the different source of power. With a 230-volt AC input, the voltage will be stepped down using a transformer. A bridge rectifier circuit converts the AC to DC. A linear regulator converts the DC to the desired DC voltage. If a phase DC adapter is used as a power source, the regulator is required to provide a regulated DC voltage. If battery is used as a power source, the regulator may still be needed to regulate the output